Hello everyone. So in this video I am going to tell you how to calculate the potential due to the spherical shell. Okay. In the first part of this video I have discussed some key points, like I have told you if we have distributed the charge on the surface of the spherical shell, then the potential on the surface of the spherical shell will be equal to the potential at any point inside the shell. तो पहले पार्ट में हमने डिस्कस किया था कि अगर हमने किसी शेल के ऊपर चार्जेस को डिस्ट्रीब्यूट किया है तो उसके सरफेस पे जो भी पोटेंशियल होगा वो उसके अंदर भी सेम पोटेंशियल एग्जिस्ट करेगा. ठीक हो गया. नाउ हेयर विल गोइंग टू डिस्कस the potential in the concentric shells. Okay, so we'll discuss the three cases here. Okay, so for this we have considered the two shells. Okay, that the radius of the first shell is small a and the radius of the second shell is small b. Okay, q1 charges is distributed on the first shell while q2 charges is distributed on the second shell. So look at here, all of you. This is the first shell and the radius is small a. q1 charge is distributed on the surface of this shell, and this is the second spherical shell. The radius is small v and the q2 charges is distributed on the surface of this shell. Okay, now we know that if we consider the first shell, then the potential on the surface of the first shell will be 1 upon 4 pi epsilon naught q1 by a. Okay, and for the second shell, the potential on the surface of the second shell will be 1 upon 4 pi epsilon naught q2 by b. Okay, similarly in the first case that is we have considered the case when the r is less than a. Okay, we'll consider a point p and where we'll calculate the net potential due to the two shell, and that point is inside the first shell. Okay, that is r is less than a. So we'll consider a point p inside the shell 1 and we'll draw a Gaussian surface from the point P. Okay, the radius of this Gaussian surface is small r. Now see, this is a point. Okay, if we see we want to calculate the potential at a point P due to the first shell and due to the second shell. So we can write the potential at a point P will be equal to the sum of the potential due to the first shell and the potential due to the second shell. Okay, so what is the potential due to the first shell and the potential due to the second shell? We'll try to understand it. Okay, now see, this point P for the first shell, this point P will act as an inside point, and we have already learned that whenever the point is inside the shell, so whatever is the surface on the whatever is the potential on the surface of the shell will be the potential inside the shell. Okay, so for the first shell this point will act as an inside point, so whatever is the potential on the first shell will be the potential at a point P. Okay, so the potential due to the first shell will be 1 upon 4 pi epsilon naught q1 by a, because this is the potential on the surface of the first shell, and that will be equal to the potential at any point inside the shell. We have already learned the concept. Okay, now due to the second shell, again see, for the second shell also this point will act as an inside point, and we know that whatever is the potential on the surface of the second shell, the same potential will be inside the shell. Okay, so the potential due to the second shell at a point P will be the potential 1 upon 4 pi epsilon naught q2 by b. So this is a net potential at a point P due to the first shell and the second shell. So पहले वाले केस में हमने देखा कि दोनों shells के लिए ये जो point P था वो internal point था, that is a inside point, और inside point पे हमें पता है first shell के कारण inside point पे potential क्या होगा, जो उसके surface पे होगा वही अंदर होगा. Similarly second वाले shell के लिए जो उसके surface पे होगा वही उसके अंदर भी होगा. Okay, so it is clear. I hope it is clear to you. Now we'll consider the second case and we'll consider the point P in the region between the two shells. So here we have considered a point P and we'll draw the Gaussian surface of radius r. Now see, again we'll calculate the potential at this point P due to the two shells, due to the shell 1 and due to the shell 2. So we'll consider it for the first shell. Look at here, for the first shell the point P is the outside point, and for the outside point due to the first shell, what will write the potential? The potential will be 1 upon 4 pi epsilon naught, as the charges distributed on the first shell is q1 and the distance is small r. So this is the potential at a point outside due to the first shell. So we can write V1 as 1 upon 4 pi epsilon naught Q1 by R. Now see, let's check the potential due to the second shell. So for the second shell, this point P is a inside point, and we know the concept, whatever is the potential on the surface of the shell will be the potential at any point inside the shell. So due to the potential, due to the shell 2, the potential will be 1 upon 4 pi epsilon naught Q2 by B, क्योंकि यही potential इसके surface पे होता है और वही potential उसके inside भी होगा. Okay. Now we'll consider the third case where R is greater than B. Means if we'll consider the point P outside the shell B. Okay, then we'll again write the potential due to the first shell and the potential due to the second shell at a point P, and the distance is R from the center of the shell. Now see, if we'll look at here, for the first shell and for the second shell, for both the shell, this point P is a outside point, and we know that for the outside point, due to the shell 1, the potential will be 1 upon 4 pi epsilon naught Q1 by R, and due to the shell 2, the potential will be 1 upon 4 pi epsilon naught Q2 by R. So this is a potential at a point P outside the shell, क्योंकि ये वाला point दोनों ही shells के लिए outside point है. So we'll simply write 1 upon 4 pi epsilon naught whatever is a charge on the first shell Q1 divided by R, and similarly Q2 divided by R. So I hope you all understand it very well. So stay tuned. Thank you.